This is abyss life, where we descend beyond intuition and into biological extremes. You are looking at a shrimp, 10 centimeters long, no claws, no teeth, no venom. And yet, this animal delivers the fastest punch ever recorded in nature, faster than a bullet, hotter than the surface of the sun for a fraction of a second. Measured by acceleration alone, its strike delivers more force than a professional heavyweight boxer, including Mike Tyson, not because it's stronger, but because evolution found a shortcut through physics. This is not a story about violence. This is a story about precision, energy, and what happens when biology pushes the laws of motion to their absolute limit. The mantis shrimp is not a shrimp. It's not a mantis either. It's a stomatopod, a classification so ancient, so separated from true crustaceans, that it split from the evolutionary tree over 400 million years ago. Before sharks had their modern shape, before trees existed on land, the mantis shrimp was already perfecting its strike. Today, there are over 450 species. They live in burrows, coral reefs, and rocky crevices across tropical and subtropical oceans. Most are solitary, most are ambush predators, and they fall into two categories: spearers, long, barbed appendages designed to impale soft-bodied prey, fish, squid, worms, fast but quiet; smashers, these are the boxers. They don't impale, they destroy. Their raptorial appendages have evolved into hardened, hammer-like clubs. And their prey, the hardest armor in the ocean: crabs with exoskeletons that would shatter your fingernail, mollusks with shells that take minutes to crack with industrial tools, clams buried beneath sand. The mantis shrimp doesn't negotiate with armor, it breaks it. This animal didn't evolve to fight mammals. It evolved to break the hardest armor in the ocean. Let's talk about the club. The dactyl club is not bone. It's not chitin in the way most crustacean shells are. It's a composite material, layered, mineralized, structured like a shock-absorbing spring. The outer layer, called the impact region, is made of crystalline hydroxyapatite, the same material in your teeth and bones, but denser, harder. Studies have shown it's tougher than many ceramics used in aircraft body armor. Beneath that, there's a region with a herringbone structure, interlocking fibers that absorb and redirect force. When the club strikes, it doesn't shatter, it heals. Microcracks form during impact. The structure absorbs them, and during the shrimp's next molt, the damage is repaired. The club is already remarkable, but the club alone is not the weapon. The real engineering is in the mechanics. Inside the limb, there's a pair of muscles. One contracts slowly, building tension. Energy is stored not in the muscle itself, but in a saddle-shaped spring made of elastic proteins and chitin. The limb is locked in place by a biological latch. The spring compresses further, more energy, more tension, and then the latch releases. The spring unloads in less than 3 milliseconds. The club accelerates from 0 to 23 meters per second. That's over 50 miles per hour. Faster than a professional baseball pitch. Comparable to a low-caliber bullet. But here's where the physics becomes extreme. The acceleration, the rate of speed change, reaches 10,400 times the force of gravity. 10,400 g. Fighter pilots black out at 9 g. At impact, the club delivers up to 1,500 newtons of force, 10,400 g's of acceleration. The numbers alone don't communicate scale. So here's what they mean. If you scaled this mechanism to human size, the energy release would shatter bone on contact. But acceleration is only half the story. When the mantis shrimp strikes, something impossible happens. The water boils. The club moves so fast that it creates a low-pressure zone directly behind it. The water can't keep up. It vaporizes. For a fraction of a second, there is a void, a bubble, and then the bubble collapses. This is called cavitation, and when that bubble implodes, it releases a shockwave. The temperatures inside that collapsing bubble for less than a microsecond reach approximately 4,400 degrees Celsius. hotter than lava, hotter than the surface of the sun. There is also light, a faint flash called sonoluminescence caused by the extreme energy release during bubble collapse. You can see it on high-speed cameras. A brief flicker, the ocean, for an instant, glowing. Here's what makes this devastating. Even if the shrimp misses, the shockwave can still kill the prey. The club doesn't need to make contact. The physics does the work. Key line, measured delivery. The animal hits twice, once with the club, once with physics itself. This is not brute force. This is a biological railgun. If you work in a public aquarium, you know the mantis shrimp by a different name. Thumb splitter. They've shattered quarter-inch acrylic, cracked reinforced glass tanks, punched through protective netting. Handlers use thick gloves, long tongs, and a lot of respect. Not because the shrimp is aggressive, but because it doesn't differentiate between a crab shell and your fingernail. There are documented cases of people requiring stitches, broken bones and fingers. One aquarist described the impact as feeling like being hit with a ball-peen hammer. But here's what's critical to understand. The mantis shrimp is not violent. It's territorial. It's defensive. It's precise. This is not rage. This is control. Every strike is measured. The shrimp knows the angle, the distance, the energy required. It doesn't waste motion. It doesn't miss often. And when it connects, the result is surgical. But there's another reason the mantis shrimp doesn't miss. Its eyes. Each eye operates independently. Each eye has trinocular vision, meaning each individual eye can judge depth and distance on its own. You need two eyes to see in 3D. The mantis shrimp has that capability twice. And then there's color. Humans have 3 types of photoreceptors: red, green, blue. The mantis shrimp, 12 to 16. So does that mean it sees a rainbow we can't even imagine? No. Actually, it's stranger than that. Recent research suggests the mantis shrimp doesn't process color the way we do. It doesn't blend signals to create a spectrum. Instead, each photoreceptor is tuned to a specific narrow wavelength. It's not seeing more color. It's recognizing patterns faster. The mantis shrimp doesn't see more color. It sees decisions faster. This is a hunting advantage. In the chaos of a coral reef, flashing fish, shifting light, moving shadows, the mantis shrimp doesn't need to interpret. It identifies instantly. And there's one more thing. The mantis shrimp can see circularly polarized light. Most animals can't. We certainly can't. But many reef creatures reflect it. Camouflage that works on most predators is visible to the mantis shrimp. It's not just punching harder, it's seeing what others can't. But evolution doesn't give gifts without cost. Every time the mantis shrimp strikes at full force, it damages its own weapon. Microfractures form, the impact region compresses. The herringbone layers absorb some of the shock, but not all of it. The only way to repair the club? Molting, shedding the entire exoskeleton and rebuilding it. And during that time, while the new shell hardens, the shrimp is vulnerable, soft, defenseless. So, the mantis shrimp lives in a cycle. Strike, damage, molt, rebuild. It's a high-risk, high-reward design. Other species evolved venom. Some evolved speed. Some evolved camouflage. The mantis shrimp evolved force. And like any high-performance system, it requires maintenance. Evolution didn't make this animal safe. It made it effective. And effectiveness in the ocean is survival. So, let's return to the comparison. Mike Tyson, one of the most powerful punchers in human history. Force measured in the hundreds of kilograms. Speed, timing, precision. The mantis shrimp doesn't punch like Tyson. It doesn't punch like anything else on Earth. Tyson uses muscle. Muscle contracts. Fist accelerates. Momentum transfers. The mantis shrimp uses stored elastic energy. A spring, a latch, a release mechanism older than the dinosaurs. The mantis shrimp isn't powerful because it's angry. It's powerful because physics allows it to be. Humans punch with muscle. This animal punches with stored energy, geometry, and timing. Mike Tyson is a benchmark, a reference point, a way to understand scale. The mantis shrimp is a system, and that system has been refined across 400 million years, not for sport, not for dominance, for survival. In the ocean, size doesn't decide dominance. Design does.